Welcome to another video on Low-Tech Empire Python tutorials. In this video, we're going to be looking at the operator precedence. So now, simply speaking, operator precedence is the priority Python will attach to an operator when they are placed adjacent to each other. So if we have multiple operators in the same expression or in a single expression, Python prioritizes some of the operators more than others. So it means some operators or the operands of some operators are evaluated before others when they are adjacent or they exist in the same expression in Python. So without much explanation, let's get into the video. Now, we're going to do a bit of reading just so we have everything intact. Operator precedence can simply be described as the priority Python attaches to a particular operator when it is present in an expression with multiple operators. To explain operator precedence, consider the code below. Now, let's pop up our interactive prompts. Now, let's look at the answer. Now 3.3, let's see if we can find out. Let's follow it straight from left to right. So 2 plus 4 is 6, divided by 6 is 1, times 2 is 2. So you see the answer doesn't really match what we expect if we are moving from left to right. So it shows Python has something it does. There's a way Python carries out expressions which has multiple operators on the same expression. You know, Python follows an order. Now, this is similar if you've done mathematics at elementary level, you will know about algebra or BODMAS, bracket of division, addition, and subtraction, where if operators are placed adjacent to each other, you need to follow the BODMAS procedure to be able to know which operator is evaluated first. So Python will follow something similar to that. For example, in this case, Python is going to consider multiplication, or let's say division. Is going to take 4 over 6 and multiply by 2, then add to 2. So let's see, 4 divided by 6. Now multiply that by 2. Sorry, let's take 0.66666. Sorry. 0.666666666 times 2. Now let's add plus 2. Oh, we need this 1.333 plus 2. So all right, now we have something similar to what we had here. So it shows to what we had in this expression. Okay. So it shows actually what Python did was Python followed the order I just followed to do this calculation. Now, we are going to look more into that. I just want to show you Python actually follows a particular order similar to that of algebra when it comes to mathematical operators. And bracket is normally the first. If you want the operation to occur in a particular way, you can use bracket. For example, if I want to change the order, I can say 2 plus 4 divided by 6 or divided by 6 times 2. In this case, we are going to have a different answer. As you can see, 0.5, because we have used bracket just like done in mathematics to specify how we want the operators to be carried out. Since bracket has the highest precedence, this is going to be evaluated, this is going to be evaluated, then the result is this is going to be divided by this. So we're going to have 6 divided by 12. So we have 0.5, that's half. So I just let's look now into this. You see other expressions like let's say b equal to 9 divided by 4, floor divided by 3, and modulus 5. If you haven't learned all our different expressions like mathematical expression, assignment, our operators, the video we made on different operators, like here we have mathematical operator, here we have now another mathematical operator, the modulus. You can watch our video on mathematical operators so you understand the difference between this floor division or modulus and all these other operators. So we are doing this as the last video on operators because Here we need to deal now with the precedence of operators. So you need to know about the operators before you can be able to understand the precedence. Or if you're already familiar with operators, then you don't have any problem watching this video. So let's now multiply by 2. Let's print out b. Now, as you can see, the answer is 0, which can look very complex. For example, if you take 9 divided by 4, you're going to get something. If you evaluate this from left, let's do it on our calculator. Now, 9 divided by 4. Normally, we have floor division here, but it's difficult to see. Now 9 divided by 4 equals to what? 2.25. Let's say 2.25 divided by 3, and we divided by 3 divided by 3 equal to, now we know floor division is going to neglect the decimal point here, so our answer is 0. 0 mod 5 is 0 times 2, we have 0. So you can see in this case the expression was actually done from left to right, but that will not be the case for other expressions, you understand. So like we have 5 times 2, yeah. So let's say if we had something like a plus here, now we can't do it from left to right. Let's print b. Now p is 8.25. Let's try to do the expression from left to right. Okay, now 9 divided by 4 plus 3 modulus 5 times 2 equal to 8.25. Wow. So we are actually following the correct precedence because 9 divided by 4 occurred first, 5 times 2 occurred second. Thus we had 9 divided by 2 first. 9 divided by 2 was first, so we had 4.5 plus 3, which gave us 7.5. Then modulus 5 times 2, so we had modulus 10. So that's why we normally have 8.25. But just like we're going to see the order it normally follows. So if you have an expression, let me look for an expression which is not going to give us the value we expect from left to right. So let's look for an expression that does that. So you need to have something like, let's say c equal to, let me craft one which is not going to give us what we expect, plus all right. So now let's look at c. Okay, let's see it's 4.0. Let's try to do our evaluation from left to right this time and see if we're going to get 4.0. Okay, 5 times 2, let's do it ourselves and we're going to see it's not going to match. Now 2 plus 3 is 5. 5 times 2 is 10. 10 minus 8 is 10 minus 8 is 2. 2 divided by 2 is 1. So if we do it from left to right without following any operator precedence, it's going to give us 1. Let me do it again. 2 plus 3 is 5. 2 plus 3 is 5. Now 5 times 2 is 10. 10 minus 8 is 2. Or 2 now divided by 2 give us 1. But if we follow operator precedence, it's going to take this. Here is going to be our answer. It's similar as doing like 2 c equals to 2 plus, it's going to be 3 times 2. Here is how Python does the computation internally. 3 times 2 minus 8 divided by 2. Here's how Python does it. So if we calculate this, you're going to see it's 2 plus 6, which is going to give us, which should be equal to 2 plus 6, which is 6, 7, 8, 8 minus 4. 8 minus 4, because 8 divided by 2 is 4. So 8 minus 4 gives us 4. So there was just a brief, some brief arithmetic calculations. If you're not able to understand that, you don't really need to understand it to understand how operator precedence work. So I just wanted to show you our calculator itself uses operator precedence, or it follows the BODMAS rule, just like Python did here to come out with 4. Our calculator itself also does the same stuff and gets 4. But in our eyes, we may have thought it moves from left to right, like it does the computation or its calculation from left to right, but that's not the case, because if we do it from left to right, as we've seen in this case, we are going to have 1. So it shows Python actually follows board mass by grouping the expressions into their different priority, and then doing now the final calculation to have 4. So let's move forward. Let's look at let's, we can be running out of time. Let's move forward. So now let's see. So here are some other expressions. For example, let's go to the next one. We can have d equal to 2 less than or equal to 5, greater than 6, greater than or equal to 5, less than 2. This one looks really complicated if you don't follow something like, if you don't follow operator precedence, you may hardly be able to understand how this is carried out. So let's move directly to the operator precedence note. So we'll see the different operators and their precedence. So now Python operator precedence comes in when you start wondering, like you see these statements above. We said Python operator precedence comes in when you start wondering which operator will be considered first to perform the following operations above. Python operator precedence for arithmetic operators follow a pattern similar to that of algebra, the popular BODMAS. If you did elementary mathematics, you may know about BODMAS. Operators have different operator precedences, as I will show you below, but some operators have the same precedence, and operators with a priority either from left, and operates with a priority either from left to right, or right to left. So now there are some operators which have the same precedence. It means like plus or minus, they have the same level of precedence. So Python evaluates them either from left to right or from right to left. We are going to be seeing some of them. So now let's go directly to a list. The following table shows a list of all the operators from highest to lowest precedence. Operators at the same level have a precedence from left to right, with the highest being the leftmost. So now here are the different operators in Python with their highest precedence. Now if you have an operator with the bracket followed by an operator with a star or exponent character, Python first evaluate that with a bracket. So I'm going to show you. Now let's look at an example. If we have 2 plus 2, 2 plus 2 um, raised to the power 2. What, of course, it's clear. We know Python is going to evaluate this within the bracket first before raising to the power 2. So it's 4 raised to the power 2, which should give us 16. Now, here are some other. Now, the exponent operator comes before plus or minus or the tilde sign. This is negation, the complement, like we learned when we did bitwise operator. So which means, for example, if we have 2 plus 2 raised to the power 2, in this case, as you can see from the right hand side here, this exponent has a greater precedence than plus or minus or whatever. So in this case, it's going to be 2 raised to the power 2, and the result, and then you're going to add 2 to it. But Python is going to evaluate this first, because this operator has a higher precedence than this operator. Not really, these two operators, they are combined together and raised to the power has a higher precedence than this operator. So Python first evaluates this, and then the result is added to 2. So let's see, it's going to be 2 plus 2 raised to the power 4. 2 raised to the power, 2 plus 2 raised to the power 2, which should be 2 plus 4, which should be 6. So we see. Now, even if we do something like 4 minus 2 raised to the power 2. In this case, star star, that's the power operator has a precedence higher than the negative sign. So this is going to be evaluated first, which is 4. Then now minus 4 minus 4 is going to give us 0. Instead, it looks like it's going to say 4 minus 2 raised to the power 2, but that's not the case because this has a higher precedence. So the answer is going to be 4 minus 4, because this will be evaluated first. This is similar to writing something like 4 minus 2 raised to the power 2. This is the same stuff. 4 minus 2 raised to the power 2. So the reply is supposed to give us, the answer is 0, the result is 0. Now let's see operators that act like you can see from this. These operators have the same um, precedence, so they actually operate from left to right. So for let's see an example: complement, unary, plus, minus, method names, and so on. So let's see some examples. Now, not false equals to -1. Yeah, you understand that's when we studied bitwise operators, we saw this is the one complement. So normally you can't even apply it to a Boolean value. Let's apply it to, let's say, 30. It gives us -31. So let's look at how they operate when they are in the same expression. Not plus 4 minus 2. So let's look at the operator. Or even let's say now, when you look at this expression, the question is which one is going to be evaluated first? If you evaluate this expression the way you like, for example, if you want to evaluate it ourselves, we are going to get the wrong answer because normally they all have the same precedence, but they can either be evaluated from left to right or from right to left. So let's look at the operator precedence. Let's look at it. So if we take 30 plus 4, here we have so since they all have the same precedence, what's going to happen is that Python is either going to evaluate from left to right or from right to left. I think in this case it's going to be from left to right. So let's look at the answer. Okay, this is supposed to be joined with this 4, right? So this is 4, I think, plus something like this. All right, so let's look how it's going to be evaluated. So in this case, we see the evaluation is 30 plus 4 is 34 minus 2. This is going to give us -3. 34 minus 3 is 31, minus 5 -26. All right, so it operates from left to right because we have 30 plus 4, it gives us 34, plus the complement of 1 complement of 2 is going to give us -3. So you have now 34 minus 3, which is 31. Let's see, 1's complement of 2, -3. 34 minus, yes, then now 31 minus 5 is going to give us 26. So it's from left to right, and that's because this and this have the same precedence, so they are evaluated from left to right. You may never need to do this in your program, so if you want to know what is happening, you are advised to use brackets. Most time when I write programs, I don't rely on operator precedence. I use brackets to know what is happening. For example, in this case, we can say 2 plus this, and let's say 30 plus 4, you can say plus, you can even say -2 times 3 plus 4, 3. I'm just showing you, if you want to really know what is happening, the best option you have is to use brackets. And I always advise you to not rely on operator precedence. Use brackets for your mathematical computations so you know exactly what is happening, except you really need to use operator precedence, or for simpler expressions. For simpler expressions, you can rely on operator precedence, but when you start having multiple operators within an expression, you're advised to use brackets so you don't get a wrong answer. It's very important you know that. So normally we just learn operator precedence to just know what it's all about. But you realize most times in your mathematical expression you want to use brackets so you're actually sure of what you're doing rather than relying on Python to carry out the operations or to prioritize the operations for you. So it's very important for you to use brackets for complex mathematical expressions. It helps you to have the correct answer and accuracy. And for others reading your code, it eases the work for them rather than them trying to compute the operator precedence of your expressions. So I think it should be very important for you to use brackets each time you're doing mathematical computation. So as you can see, the next one is star divided, modulus, and floor division. So these all have the same precedence. They have the same precedence, and but they're evaluated from left to right. But as you can see, plus has a higher precedence than times. It should not be. All right. So this, I think these are unary. All right, these are actually unary operators. I made a mistake initially. These are unary operators. This plus is not like the plus for mathematical operators. This plus is like plus 1 minus 2 plus 1's complement of 3. So this plus is unary plus. For example, if you have minus 1 plus 3 minus 2. So as you can see, what we're trying to say, these unary operators and this unary operator has a higher precedence than this binary operator, because as you can see, these are binary operators, but this here is a unary operator because you just say minus 2, it means negative 2. So we are going to have 3 minus negative 2, which is usually 3.2, and here we're going to have negative 1 plus 3. So it's showing these unary operators have higher precedence than these binary operators. So unary plus has a higher precedence than binary plus. Unary negative has a higher precedence than binary negative. You understand? So that's what it actually means. So now we see the next part. We have multiplication, division, modulus, and floor division. Modulus and floor division. So the next operator we have is addition, subtraction. Here we have bitwise and all these operators. So you can use this in your free time to actually check it out. But like from what we have explained, I guess you fully understand what operator precedence means. So if this operator, for example, star appears in the same expression with plus, the star will be evaluated first. For example, if you have 2 times 2 plus 3, it's going to first do, or if you have, let me do it the other way, 3 plus 3 times 5. It's not going to do 3 plus 3 first before multiplying by 5. Why? Because this asterisk sign, as you can see here, has a higher precedence than the binary plus sign, addition and subtraction. You understand? It has a higher precedence. So what's going to happen is that this will be evaluated first. This will be evaluated first before this. So it's going to be 3 plus 3 times 5. So 3 times 5 will be evaluated first, which is 15. Then now 3 is going to be added to 15. So you're going to have a result, it is 18. So that's what actually. So now here we have right shift and left shift. As you can see, right shift and left shift appear after that's below plus. So if you have let's say 4 left shift 2 plus 3, it's similar to say it's first going to take 2 plus 3, then it's going to find 4 left shift the result of 2 plus 3. So this is similar to writing 4 left shift 5. You understand? Instead, if it was not that case, we would have had 4 left shift 2 first, then plus 3. But you see, that's going to be wrong. If you have 4 left shift 2, 16 plus 3 does not give us 128. So this will be evaluated first, because plus has a higher precedence than the left shift operator. As you can see, plus appears before left and right shift. Left and right shift have left and right shifts have the same precedence, so they are going to be evaluated from left to right. For example, if you write 3 right shift 4 left shift 5 4, it's going to first do this, then later do this. So it's going to be 3 left shift 4, then now 4 right shift 4. So let's see, is it left to right or right to left? 3 right shift 4 and 4 left shift 4. So as you can see, this one is from right to left, not left to right, because it shows it took 4 left shift 4. Let me try it. 4 left shift 4, and now 3 right shift 64. All right, so as you can see, this one, let's use bigger numbers. 128 left shift 2 right shift 100. Okay, let's see now if it's from left to right or right to left. Now let's take 128 left shift 2 30, then let's take 32 right shift 100. All right, let's now try it from left to right. Let's take 2 left shift 100. Wow, that one is so big. We cannot even do 22 right shift this. It's gonna and 128 128 right shift this, so big. So big, gives us 0. So as you can see, what proves is that this they have the same precedence, but this is always evaluated first and this is evaluated second. So they have the same precedence, but this is evaluated first and this is evaluated second. So as you can see in this expression, this will first be evaluated, this will first be evaluated, then now later on this will be evaluated. But if we inverse it, in this case, this will be evaluated, then this will be evaluated. As you can see, 128 2, then we can say now 32 100. So that's what happened. So but if we change it, maybe we put this to be left shift, you see this is going to be evaluated first, then followed by this. Let's see the answer of this one. It's going to give us 0. So you can see this has a higher precedence than this. So I want you to take note from the table here. When multiple operators have the same precedence, then you can follow this pattern. This will have a higher precedence than this, which will have a higher precedence than this, which will have a higher precedence than this. Operators actually have a precedence from left to right when they are in the same when they are in the same expression. They can evaluate either from left to right or right to left. Yeah, you just need, that's why it's always good to use brackets, because you can't know except you look for a table. In this table, I did not actually specify if the precedence is from left to right or from right to left, because look, for example, if we have this expression, yeah, if we have this expression 8 floor divided by 2 times 3, normally let's get the answer. We have 12, which showed it first did 8 divided by 2, which gave us 4, then it multiplied by 3. So as you can see, this actually happened from left to right. As you can see, it's always from left to right, So let's see again. If we have times and divided by, the answer now is 5 because it operates from left to right. So in this case, we had since, and you need to know it does from left, it actually evaluates from left to right because they have the same precedence. As you can see from here, we have the same precedence. So when they have the same precedence, most times evaluation is from left to right. So as you can see, this was from left to right. So it's always good to use brackets if you want a specific outcome and you don't want to rely on operator precedence. So as you can see, we, this exclusive or comes before or, less than. So in the case if we have 3 less than or equal to 4 greater than 5 less than 6. Now in this case, evaluation is going to be from left to right because it's 2 less than or equals to 5. Let's see the answer. False. Is 2 less than or equal to 5? Yes, it's less than 5. So true is true. That's 1. No, now the answer is true. So is true greater than 5? False. Is false now is 0. Is 0 less than 6? So let's check it out. 2 less than or equals to 5. Let's see. Looks like this one is from right to left. Let's check. Is 5 less than 6? Is 5 less than 6? Yes. So we have true here. Is 5 greater than true? Yes. Is 2 less than or equals to true? No. No, 2 is greater than true because true is equal to 1. So as you can see in this case, it's from right to left. So you're never really sure whether it's from left to right or right to left. In this case now, you can see it's from right to left because if you start evaluating from this point, it's going to give you something else. If you start evaluating from this point, it's going to give you something else. So for example, if we start from the front, we can say 2 less than or equals to 5 is going to give us true. Now, true is 1. 1 greater than 5 is going to give us false. Now, false is 0. 0 less than 6 is supposed to give us true. Okay, so it gives us false, which means it started evaluating from this side. So to be sure of your expression, it's always good to use braces because Python can do left to right or right to left. As for in this case, if you take right to left, 5 less than 6, true. True is 1. 5 greater than 1, true. Now 2, true is 1. Now 2 less than or equals to 1 is false, so it returns false. So just take note of that. So basically that's basically the idea of this operator precedence. You actually can see other examples here. You can see other examples from here and here. So you can see we have 2 plus 4. So the best stuff, like I said, is to use here are the for the membership. It has a higher precedence than is not, or is not in and not in, not or, and have the at the lowest at the bottom of the precedence of precedence. So for example, if you have 2 plus 3 and 3, it's going to first do 2 and 2 plus 3 before the reply is going to the result of 2 plus 3 is going to be AND with 3. So 5 and 3 is going to give you 3. So that's okay. So I just wanted to see from this table. We are not going to be able to look at all because we are running out of time. So I just wanted to look at the table. You see these ones come below the comparison operator, and this equation, the assignment operator, comes below the equality operators, while the identity operators come below the assignment operators, and the membership operators come below the identity operators, and the logical operators are the last on the list. So they have the lowest precedence in any expression. So the best stuff you can do is to use brackets. For example, such an expression, you see Python will apply the brackets where necessary. Since star multiplication has a higher precedence than division, Python is going to evaluate multiplication first. You get now a result. Since division has a higher precedence, Python is going to evaluate division first, get the result, then it's going to do this one last, or this is going to be the next, because plus has a higher precedence than and. So after doing this, Python now is going to do this last one, 2.33 and true. And you know this is a truth value, so your final result is true. In this other example, Python is going to take 9 divided by 4. In this other example, Python is going to take 9 divided by 4, but see, star has the highest precedence, so it's going to be evaluated first. That's the multiplication sign, followed by the division sign, then followed by the modulo sign, because it has a higher precedence than the floor division, and lastly floor division. So in this other case, Python is going to do less than or equals to first, because it has a higher precedence, followed by less than, then followed by greater than, then lastly greater than or equal to. As you can see from here, it goes from left to right. So I just wanted to see that. So these stuff may be difficult to follow up, so your best option is to use brackets in your expression. If you have an expression and you want a correct answer, your best option is to use brackets to make sure it's evaluated the way you want it to be done. So here is an example. As you can see, we have 2 plus 4 divided by 6 times 2. You see, Python is going to follow the rules of operator precedence to get the answers you actually see here. So your best option is to do something like this. Use brackets. Use brackets to be sure of your result, like how we did here. You see how we use brackets here. So use brackets to be sure of the results you want in any expression you have. And brackets can be used for other expression, not only mathematical expression. For example, we can say 2 less than 3 and 4 greater than 5. You can say even or 2 mod 3. So or can say in 2 3 4 is or let's say less than 3. So sorry, we missed something. Right. Okay, so you can use brackets within any kind of expression. It must not be a pure mathematical expression where you have 2 3. You see where we have less than sign, but we are using bracket to separate our expressions together, so that we can be sure of the output we expect. So you can use brackets to separate smaller expression within a statement. You understand? So your best option is to use brackets to be sure of your result or output. All right, this video has really been long. We'll end here, and in the next video we are going to look at an example. Then the following video we are going to start with decision making, where we're going to see the if else and if elif and later on the for and the while loop. All right, so have a nice time and see you later.